Okay. So problem statement: a cantilever AB 2 meter long is carries uniformly distributed load of 20 kilonewton per meter over a length of 1 meter from the free end. To stop. Find the slope and deflection at the free end. Take E 200 Gpa and I it is 50 into 10 raised to power 6 mm raised to 4. Okay. So this one modulus of elasticity and moment of inertia it is given. Okay. So first of all, consider whole cantilever beam A to B as an uniformly distributed load. Okay. Just consider whole cantilever beam A to B uniformly distributed loaded uniformly distributed load. Okay. So actual uniformly distributed load it is applied C to B only. Okay. So just we assume this one, the load it is full of on this span A to B. Okay. Just assume this one it is uniformly distributed load, it will be A to B. Okay. Okay. So now apply this one. First of all, consider, you can write down this one, it is first point. Okay. The second point it is apply upward uniformly distributed load, uniformly distributed load, apply upward uniformly distributed load from A to C, okay, from A to C. So just apply the uniformly distributed load A to C in upward direction. Okay, so quantity is same, that is 20 kilonewton per meter. Okay. So A to C it will be also 20 kilonewton per meter. The whole the span it will be also same. Okay, so this one it is also 20 kilonewton per meter. Okay, 20 kilonewton per meter. 20 kilonewton per meter. Okay, and this above it is also whole the span it is also 20 kilonewton per meter. Okay, this one it is just assume. Okay, now consider section XX. Third one, consider section XX at a distance x from B at a distance x from B. So this one it is considered section XX at a distance x from B. The distance x from B. So moment at XX is equal to mxx is equal to, so first of all this 20 kilonewton per meter, so it will be 20 into, so how it is rotating about the xx, it is in clockwise direction. Here how it will be rotating, so it is rotating clockwise direction, so it will be positive. So left side, sorry, section right side, if it is clockwise then it will be take negative, minus 20 into x into x by 2, that is means x square by 2. You can write down minus 20 into x square by 2, x into x by 2, it will be x square by 2, x square by 2, x square by 2. Okay, so first of all this UDL load point, convert it is in point load, that is in 20 into x, so it will be acted center of this x, means x by 2 from section xx. So first of all, load it is 20 into x, and perpendicular distance it is x by 2. So it will be get minus 20 x square by 2. So this one it is now upward. Now this one it is upward. Okay. So this UDL load now consider. So first of all, this UDL load distance it will be how much? This distance here. Total it is x, and this distance it is 1. So means it will be get x minus 1 in bracket x minus 1. Okay. So again UDL, it will be how it is rotating. It will be rotating about the x. It will be anti-clockwise direction. So left, right side anti-clockwise it will be take positive. Okay. So that's why it will be 20 into in bracket. First of all, convert it is in point load x minus 1. Then it will be acted center of this. That is means x minus 1 square by 2. X minus 1 square divided by 2. X minus 1 square divided by 2. Okay. So first of all, this point load 20 kilonewton per meter, converted it is in point load, means 20 into x minus 1. So where it should be acted? Center of this x minus 1, means x minus 1 by 2. It will be 20 into x minus 1 square by 2. Okay. This one it is moment at x-axis. Now as per the Macula's equation, EI d2y by dx square d2y by dx square d2y divided by dx square dx square dx square is equal to moment at x-axis, is equal to moment at x-axis. Okay. Now put EI d2y by dx square d2y d2y divided by dx square dx square dx square is equal to, now moment at x-axis it will be minus 20, means it will be 2 on the 2, 2 10 the 20. This one also 2 on the 2, 2 10 the 20. So just simplify this one, it will be minus 10 into x square, minus 10 into x square, minus 10 into x square plus 10 into in bracket x minus 1 bracket square, x minus 1 bracket square, x minus 1 bracket. So this one it is equation number 1. So integrate with respect to x. Now integrate with respect to x, equation 1. Equation 1. Integrate with respect to equation 1. So EI d2y by dx square, it will be dy by dx is equal to minus 10 into x square derivative of, sorry, integration of x square minus 10 into integration of x square, it will be x cube by 3, x cube divided by 3, x cube divided by 3 by 3, then plus integration of x minus 1, it will be in bracket x minus 1 cube divided by 3, x minus 1 cube divided by 3 plus c1 Okay. So So this one write down equation number 2. Number 2. Again integrate with respect to x. Again integrate with respect to x. So it will be ai divided by dx, it will be y is equal to minus 10 x cube by 3, it will be x raised to 4 divided by x raised to 4 divided by x raised to 4 divided by 4. 4 3s are, now it will be 12. 4 3s are 12. Then plus same here 10 in bracket x minus 1 raised to 4 raised to 4 raised to 4 divided by 12 divided by 12 plus c1x plus c2 plus c2 plus c2. So this one it is equation number 3. Equation number 3. Equation number 3. Equation number 3. So apply boundary condition now. Apply boundary condition. Boundary condition. Boundary condition. So when x is equal to 2 meter, so dy by dx is equal to 0. Dy by dx is equal to 0. Okay. Dy by dx is equal to 0. Okay. So here, when you apply force on that beam, so beam it will be deflect in that way. Okay. In that way. Okay. I will show you in red color or black color. Okay. So here, this it will be deflect in that way. And slope and deflection at A it will be 0. Okay. Slope and deflection at A it will be 0. So put in equation 2. Put in 1. Put in 1. Okay. So dy by dx it will be 0. 0 is equal to, so minus 10 into x it will be 2. 2 cube divided by 3. 2 cube divided by 3. 2 cube divided by 3. 3. Then plus 10 into 2 minus 1, it will be 1 cube divided by 3. 1 cube divided by 2 minus 1, it will be 1. 1 cube divided by 3. 3 plus c1 plus c1. So from this relation, it will get c1 value. So I will write down here. C1 is equal to, write down. C1 is equal to. C1 is equal to. First of all, simplify this. 0 is equal to 2 raised to 3 divided by 3 into 10 minus 26.67. Then plus 10 divided by 3 will be 3.33 plus C1 plus C1. So C1 is equal to minus 26.67 minus 26.67 plus 3.33. So it will be 23.34. 23.34 C1 value. Okay. So now apply second boundary condition. Apply second boundary condition. Boundary condition. When x is equal to 2, y is equal to 0. Y is equal to 0. put in equation 3. Okay, put in equation 3. Put in equation put in equation 3. Put in equation 3. Okay, so I'll write next. So ey by I is equal to 0. Then minus 10 into 2 raised to 4 divided by 12. 2 raised to 4 divided by 2 raised to 4 divided by 12. 2 raised to 4 divided by 12. Then plus 10. Then 2 minus 1, it will be again 1. 1 raised to 4 divided by 12. 1 raised to 4 divided by 12 divided by 12. Then plus C1 value, we know that C1 value it will be how much? We are calculated, it is 23.34. C1 it is 23.34. 23.34 into 2 and plus C2 and plus C2. Okay. From this relation it will be get C2 value, okay, is equal to 0 is equal to, first of all, 2 raised to 4 divided by 12 into 10. 2 raised to 4 divided by 12 into 10, minus 13.33 minus 13.33 plus 10 divided by 12, it will be 0.833. Then plus 23.34 into 2, so it will be 46.68. 46.68 plus C2 plus C2 plus C2. Okay. So write down C2 is equal to so minus 13.33 plus 0.833 plus 46.68. So C2 is equal to 34.183. 4.183 and C1 it is 23.34. So put C1, C2 value in equation 2 and 3. So right here, put C1 and C2 value, in equation 2 and 3. 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 So first of all, put in 2. So it will get EI dy by dx EI dy by dx is equal to minus 10 into x cube by 3, x cube divided by 3 cube divided by 3, then plus 10 into, in bracket, x minus 1 cube divided by 3, x minus 1 cube divided by 3 divided by 3 plus C1 So this one it is slope equation. You can say it will be slope equation. Okay. So now put in equation number 3 for getting the deflection equation. So now EI into I is equal to minus 10 into x raised to 4 x raised to 4 divided by 12 then plus 10 in bracket x minus 1 raised to 4 x minus 1 raised to 4 divided by 12 plus c1 value we know that c1 it will be 23.34x then plus c2 it will be minus. Okay, so actually this one it will be minus value c2. Just I will cross check minus 13.33 plus 0.833 plus 46.68. Okay, so this one it will be minus c2 it will be minus value. Okay, minus 34.183. So this one it is deflection equation. Okay, so this one it is deflection equation. Okay, deflection equation. So now we need to calculate slope and deflection at free end. Okay, slope and deflection at free end. Now slope at free end. First of all, slope at free end. That is means at B. At B. Okay. So put x is equal to 0 and dy by dx is equal to theta b. Let's say theta b in equation, in slope equation. Let's say in slope equation. Okay? In slope equation. So first of all, calculate EF for that. So we know that E is equal to it is 200 GPa. So convert it is in Newton per mm square. That is 200 into 10 raised to the power 3 Newton per mm square. Okay? And I it is given. I is equal to 50 into 10 raised to the power 6 10 raised to the power 6 mm raised to 4 So now EI is equal to calculate. EI is equal to 200 into 10 raised to the power 3 into 50 into 10 raised to the power 6. So it will be get 1 into 10 raised to the power 13. 1 into 10 raised to the power 13 Newton mm square. So we need to get Newton mm square. Okay, so convert it in kilonewton per meter square. So we need to convert it in kilonewton per meter square, means divided by. So EI is equal to, so 1 into 10 raised to the power 13, 1 into 10 raised to the power 13 divided by 1000 into, so first of all convert Newton to kilonewton, means divided by 1000, then mm square to meter square, means divided by 1000 square. Okay. So for Newton to kilonewton divided by 1000, mm to meter square divided by 1000 square. Okay. So it will be get kilonewton meter square. Okay. Divided by 1000 into 1000 square. So it will be 10 into 10 raised to the power 3 kilonewton meter square. Kilonewton meter square. Okay. Kilonewton meter square. So I will write down EI is equal to here. EI is equal to 10 into 10 raised to the power 3 kilonewton meter square. Kilonewton meter square. I will note down this value. Okay. Kilonewton meter square. So now to put x is equal to 0, dy by dx is equal to theta b in equation, in slope equation. So this one it is slope equation. Here, this one it is slope equation. Okay. So ei dy by dx it will be theta b is equal to now x is equal to 0. So x is equal to 0. So 10 into x cube by 3 it will be, this term it will be 0. Then plus 10, 0 minus 1 raised to cube divided by 3. If it get 0 in bracket, when you solve this bracket, so x minus 1. So 0 minus 1. So minus, if you get minus, then it will be take 0 directly. Okay. Then plus C1 it will be 23.34. C1 it will be 23.34. So theta b is equal to, write down, theta b is equal to 23.34. Theta b is equal to 23.34 divided by EI. EI value it is 10 into 10 raised to power 3. 10 into 10 raised to power 3. Okay. It will be theta b. 23.34 divided by 10 into 10 raised to power 3. It will be 0.00233 radians. 2334 radians. Okay. Radians. Okay. So this one it is slope at B. Now we need to calculate deflection at B. Okay. So deflection at B. So we need to deflection equation for that. Deflection at B. So deflection at free end. Now we need to calculate deflection at free end. Free end means at B. Or at B. Okay. So put x is equal to 0. And y is equal to yb in deflection equation. In deflection equation. In deflection equation. Okay. So ei yb is equal to, so this one it is deflection equation. So minus 10x raised to 12. So this term it will be get 0. Then plus 10x minus 1 raised to 4. That is, this term it will also get 0. Okay. So if it is any value get in bracket 0 minus, so you will take directly, it will be 0. Okay. So then plus 23.32 into x, it will be 0. So this term it will be also 0. Then minus 34.183. Okay. So yb is equal to minus 34.183 divided by ei. Ei it is 10 into 10 raised to power 3. 10 into 10 raised to power 3. Okay. 34.183 divided by 10 into 10 raised to power 3. It will be minus 3.418 into 10 raised to power minus 3 in meter. Convert it is in mm. Multiply by in 1000. multiply by 1000. It will get 3 minus 3.418 mm. So minus indicates the deflection, it is in downward direction. That's why it will get deflection in downward direction. So that's why we have got this value in negative. Okay, minus 3.418 mm, and slope at B it will be 0.002334 radian. So this one it is solution of slope and deflection at the free end. Okay, by Mackler's method.